So let's start with the base with the questions of integration from the past paper. So as you can see, the first one is dy by dx is equals to 4x cube plus 1. So you need to find the equation of y. So for finding the y, we'll just integrate. So we'll get y is equals to 4, and as you can see, x to the power of 3 is nothing but x to the power of 4 upon 4. So we'll get like this, plus integral 1 is nothing but x plus c. C is just an arbitrary constant. So 4 cancel, we get x to the power of 4 plus x plus c. Now see, 2 comma 17 is in is passing through the curve, or the curve is passing through 2 comma 17, so it must satisfy the equation. So we'll just substitute and we'll get c is equals to -1. That will substitute here and we'll get this equation. Very simple, that's why I didn't solve it properly. Now what about this thing, ddx of 5 upon 3x plus 2? Again, differentiation, so we'll just do it normally. Chain rule we are going to use, 5 constant outside, what is it, -1 into 3x plus 2 to the power of -2, yeah, into derivative of 3x plus 2, which is nothing but 3, right, which is nothing but in turn it will give me -15 upon 3x plus 2 to the power of 2. Now using your answer of part 1 to find this thing. Now see here, this integral can also be written as -2. I'll take out -2 common. This is nothing but -15 upon 3x plus 2 to the power of 2. Why I'm doing this thing? Because I'm trying to make this as this. Because now if I integrate this equation, like just from, let's say this is from 1. So from 1, if I just integrate dy is equals to integral -15 upon 3x plus 2 to the power of 2 dx, I'm gonna get what? I'm just gonna get y, and this integral is nothing but then y. So this in turn will give me -2y, right? And y was nothing but 5 upon 3x plus 2. So we'll get -2 into 5 upon 3x plus 2, which in turn will give me -10 upon 3x plus 2. That's my answer. Hence evaluate 30 upon 3x plus 2 whole square. So basically they are just asking you to evaluate this thing. So it's going to be -10 upon 3x plus 2. Of course, don't forget that c. So plus c. Minus n from 1 to 2. We'll just substitute the value and we'll get the answer. It's going to be what? It's going to be -10 upon 6, 3 into 2 plus 2, which is nothing but 6 plus 2, minus minus 10 upon, again I'll substitute, so it's gonna be 3 plus 2. So at the end what I'll get -10 by 8 plus 10 by 5, which in turn will give me minus 10 by 5 minus 10 by 8, and that is nothing but 80 by 80 minus 50, which is 30 by 40, and that will give me 3 by 4. So that's my definite integral. Look at this question. This is d2y by dx square is equals to 6x plus 2 by x cube, and when x is equals to 1, y is equals to 3, and dy by dx is equals to 1. Now see, they have said when x is equals to 1, y is equals to 3, and dy by dx at the same condition is equal to 1. So since it's double differentiation, we'll have to integrate it twice as well. So if I integrate once, so I'll get dy by dx is equal to, now integral 6x is nothing but 6 into x square by 2 plus integral 2 by x cube. Now see, 1 by x cube is nothing but x to the power of -3. So integral of x to the power of -3 is nothing but x to the power of -2 upon -2. So it's going to be plus 2 into x to the power of -2 upon -2 and plus c, of course. So this is going to be what? This is going to be 3x square minus 1 by x square plus c. Now the thing is, they have said dy by dx is equal to 1 when x is equals to 1. So I'll just substitute there. So basically dy by dx at x is equals to 1 is nothing but 1. So I'll just substitute here. I'll get 3 times 1 square minus 1 by 1 square plus c is equals to 1. So I'll get 3 minus 1, which is nothing but 2 plus c is equals to 1, or c is equals to -1. So this is one value. We can just put it there and we'll get dy by dx is equal to 3x square. I'll just write it in this form, minus x to the power of -2 minus 1. Again I'll integrate, so I'll get what? I'll get y is equal to 3 into x cube by 3 minus x to the power of -1 upon -1 minus x plus d. This time I'll take, Okay, you can take c also, that's not a problem. At the end of the day, we are just going to get the value. Again, they have said that when x is equals to 1, y is equals to 3, so we'll just substitute here. So 3 is equal to, this is going to be 1, 3 3 cancel. This is again going to be minus 1, and minus 1 plus d. uh, yeah, just a second, I think, one sec, this is going to be plus 1. Yeah, this makes sense. So therefore 3 is equal to 1 plus d, or we'll get d is equals to 2. So at the end of the day, if you see, the equation is going to be y is equals to x cube plus 1 by x minus x plus 2. I just substituted this in this equation and we'll get the value. Let's go further. Now here we have integral of 1 upon 10x minus 1 to the power of 6, very basic. So as you can see here, as I told you, we can consider this thing as x. We can consider this thing as x if the coefficient of x, we just keep it in the denominator. So it's going to be 1 by 10. Now we can consider this thing as x, and integral of 1 by x to the power of 6. So maybe if you want, you can just write down that like this. Maybe we'll just write it like this: 10x minus 1 to the power of minus 6. The moment I just put the coefficient of x in the denominator, I can consider this thing as x. Now integral of x to the power of minus 6 is nothing but 10x minus 1 to the power of minus 5 upon minus 5. So as you can see, the answer is going to be 1 upon minus 50 10x minus 1 to the power of 5. That's your answer. Now we have got this one as well: 2x cube plus 5 to the power of 2 upon x. First thing you will think of that this is a function under function, so obviously the derivative of whatever is inside should be there next to dx, but it is not there because derivative of 2x cube is 6x square, even x square is not there, so obviously this is not the way. So what we are going to do, since it is square, we are just going to expand it. So 2x to the power of 3 square is going to be 4x to the power of 6 plus 20x cube plus 25 upon x, which can be written as, I'll just distribute it from the denominator. So I'll get 4x to the power of 5 plus 20x square plus 25 by x. This is simply going to be, acha, I just forgot this plus c, so I'll just write it down here. So this is going to be 4 constant outside, x to the power of 6 upon 6 plus 20 constant outside, x to the power of 3 upon 3 plus x to the power of 0 upon 0 you cannot put it, so it's going to be 25 ln x plus c. At the end of the day, the final answer is going to be 2 by 3 x to the power of 6 plus 20 by 3 x to the power of 3 plus 25 ln x plus c. That's your final answer. Quite simple. Differentiate y is equal to tan 3x plus 1. Again, we can consider this thing as x when, if I just, sorry, we are talking about derivatives, I just forgot. Dy by dx directly is going to be sec square 3x plus 1 into derivative of whatever is inside. So derivative of 3x plus 1 is nothing but 3. So we'll get dy by dx is equal to 3 sec square 3x plus 1 plus c. What they are asking, they are asking integral of this whatever thing is. Now here, if I just write this thing as 1 by 3 dy by dx is equal to sec square 3x plus 1 like this. Okay, I'm just avoiding the c, and if I integrate both sides, so integral of this thing is nothing but 1 by 3 like this, or even you can do it directly as well. I mean, I won't mind. Hence find is not even necessary because we directly know that the integral of sec square is nothing but tan x. So here what I'm going to do, I'm just going to do tan, first of all I'll just, whatever the coefficient of x is going to be 1 by 3. Now I can consider this thing as, and also 1 by 2 constant outside. Now I can consider this sec square 3x plus 1 as just x, so it's going to be tan 3x plus 1 minus integral of sin x is nothing but derivative of cos x is minus sin x, so it's going to be plus, like minus or minus, it's going to be minus cos x. Roots from roots, not roots, sorry, the values from pi by 12 to pi by 10. Now you just need to substitute that. I don't have enough space, so I'll just write down here. So as you can see, it's going to be 1 by 6 tan 3x plus 1 plus cos x, and the values are from pi by 12 to pi by 10. We'll just substitute this pi by 10 here, so we'll get what? We'll get 1 by 6 tan of 3 into pi by 10 plus 1 plus cos pi by 10 minus 1 by 6 tan of 3 pi by 12 plus 1 minus, see again here it's minus, it's going to be in bracket, so that's why minus minus it's going to be minus cos of pi by 12. You just have to put it in the calculator and get the answer, that's it. Now what about these questions? So as you can see, there is this curve. So there's this curve where OP and RQ are basically the point of intersection. So these two curves, that is PQ and this PQ, like this, the straight line is getting intersected on this point. So we need to find this coordinate. As you know that in area under the curve, we just need to find the coordinate and we'll just find the integral over PQ, that curve thing, minus integral of that trapezium thing. So that's going to be the area under the curve. So they are first asking the find the coordinates of Q. So obviously what we are going to do, we are just going to substitute y is equals to 5 plus root 10x in this equation, or maybe you can just multiply by 4 and subtract it, it's your choice. I'll prefer substitution. So we have these two equations, that is, and they have given, yeah, by the way, the coordinate is 0 comma 5. So what we are going to do, we are just going to substitute, instead of y I'm just going to substitute 5 plus root 10x, and that is nothing but equal to 5x plus 20. Now we are just going to multiply 4 inside, so it's going to be 20 plus 4 root 20 plus 4 root 10x, yeah, this is all inside, which is equals to 5x plus 20. This 20 got cancelled, and we'll get 5x is equals to 4 root 10x. Now see, we are not we're not comfortable with this root thing, so what we are going to do, we are just going to square both sides. So we'll get what, we'll get 25x square is equals to 16 into 10x. And see, one of the coordinates is 0, so I can cut, see, you shouldn't cut it, but I can cut it because one of the coordinate is 0. Generally we just take it on the left hand side and then solve it, so it's a different procedure. So we'll get what, we'll get 25x is equal to 160, or x is equals to 160 by 25, which is going to be 32 by 5, and that is nothing but 6.4. So what about the coordinate? So for the y, I don't think so we require y coordinate. Yeah, for the trapezium maybe we will require. So that's why we'll just find the y coordinate as well. So I'll just put it in one of the equations. So we have 4y is equals to 5x plus 20, right? 5x plus 20. I'm just writing it here so that I can use it. So I'll get 4y is equals to 5 times 32 by 5 plus 20. 5 cancel. 4y is equal to 52, or y is equals to 13. So as you can see, the coordinate is going to be 6.4 comma 13. And obviously they have asked you area under the shaded region. So now we know the coordinate as well, which is 6.4 comma, how much it was, 13. So obviously what we are going to do, we are going to find area under the curve from, with respect to this PQ curve, which is 5 plus root 10x. So 5 plus root 10x, okay, and it's starting from 0 and it will go on till 6.4. So 0 to 6.4 minus area of the trapezium, which is OPQR, which is OPQR. So we'll solve individually and we'll find it. So for this one, as you can see, 5 plus root 10x, so it's going to be 5x plus root 10 constant outside. Integral of root x is nothing but x to the power of 3 by 2 upon 3 by 2. Yes. Okay, and obviously the limits are from 0 to 6.4. We're just going to substitute here. So we'll get 5 times 6.4 plus root 10 times 6.4 to the power of 3 by 2 multiplied by 2 by 3, and then minus, since x is 0, so 0, and here also it's going to be 0, so 0 plus 0, it's going to be at the end 0. That's going to be our integral ka value. So this is going to be 5 times 6.4 is nothing but 32, plus this will have to use calculator. So this will give me 34.13, and at the end this is nothing but 66.13. So this is the value I'm getting with respect to integral. Now if I talk about this OPQR, whatever this trapezium, so here so we know the trapezium formula is what it's going to be. Here as you can see, the trapezium formula is going to be, these are the parallel sides, so sum of the parallel side, OP is nothing but 5, I mean 5 steps up, so 5, this 5, this is nothing but 13, okay, and this height is going to be how much, this is nothing but your x coordinate, how much it has gone, so it's going to be 6.4. So as you can see, the formula for this thing is going to be sum of average sides, so average of the two sides, so 5 plus 13 by 2 into height, which is nothing but 6.4. So as you can see here, it's going to be 18, 5 plus, I'll just write it again, so it's going to be 5 plus 13 by 2 into 6.4, which is nothing but 18 by 2, which is 9 into 6.4, which is nothing but 57.6. Now we are just going to find that area of the shaded region. So area of the shaded region is going to be 66.13 minus 57.6, which in turn will give me minus 8.53. 8.53, is there given any units? No. 8.35 square units. That's going to be your answer for this question. Again, I have taken one more area problem. So as you can see here, this is little weird, that's why I have taken this problem. Now in this thing, they are asking you to find the coordinates of A and B first. Obviously it will require to find out the area and all. And at the end of the day, we need to find the area of the shaded region. Obviously this is the shaded region, by the way, if it's not visible. So for A, now this is the line, of course, y is going to be so here y is going to be 0. So if I just put y is equals to 0, because it's just the x-intercept, so if I put y is equals to 0, so I'll get 2x plus 0 is equals to minus 5, or x is equals to minus 5 by 2. So therefore the coordinate of A is going to be minus 5 by 2 comma 0. Now B is what? B is the point of intersection of 2x plus y is equals to minus 5 and xy plus 3 is equals to 0. So what we are going to do, we are just going to solve the equation. So one sec, yeah, so from this thing, from this equation, we can write y is equals to minus 2x minus 5. Okay, if that will work, fine. So what we are going to do, we are just going to substitute that thing. So we'll get x into minus 2x minus 5 plus 3 is equals to 0. So we'll get minus 2x square minus 5x plus 3 is equals to 0, or we will get 2x square plus 5x minus 3 is equals to 0. We'll just use splitting the middle term. So we'll get what? We'll get 2x square plus we have to factorize 6 in such a way whose difference is 5. So 6x minus x minus 3 is equals to 0. 2x common, we'll get x plus 3. From here we take out minus 1 common, you get x plus 3 is equals to 0. So you'll get what? You will get 2x minus 1 is equals to 0, or x plus 3 is equals to 0, or x is equals to 1 by 2, x is equals to minus 3. Now see, obviously x is the positive side, so we'll just consider this 1 by 2 as the answer. So the coordinate of B is going to be, x coordinate is going to be 1 by 2, and if I just put 1 by 2 in this equation, I'll get y is equals to, I'll just shift that to minus 6 right here. Minus 6 is going to be the value. Obviously I'll just use this equation, 2x plus y minus 5. So I'll just use it here. So it's going to be 2 times 1 by 2 plus y is equals to minus 5, or 1 plus y is equals to minus 5, y is equals to minus 6. So these are the coordinates we'll get. So B coordinate is going to be 1 by 2 comma minus 6. Now we know the coordinates, we can find the area of the shaded region easily. For that, what we will do, we'll just make an additional construction like this. Now we'll divide the shape into two parts. One would be this region and the other one would be this region. Okay. Now for this region, it is very easy. So let me consider this thing as A and B. So at the end of the day, we need area of triangle AMB, which is a right angle triangle AMB, plus area under the curve BC with respect to this thing. Okay, now this is interesting that we are finding the area under the curve from 1 by 2 to whatever this point is, and with respect to this function. So from this to M, I'll write it saying MBCD, area of, not actually MBCD. area of triangle AMB is very easy. So as you can see, we just need the length of this thing. So see, obviously this coordinate is going to be what? It's going to be x is going to be 1 by 2. Y is going to be 0 here. Okay. And here a coordinate was how much? A coordinate was minus 5 by 2 comma 0. Now the distance between AM, so area of triangle AMB, it's going to be half into AM into MB, half into AM into MB. So this is going to be half into AM. Now AM is how much? AM is going to be, see, you can use distance formula logically also. If you see minus 5 by 2 minus 1 by 2, so it's going to be minus, I mean, it's just it's minus 5 by 2 on left hand side and 1 by 2 on the right hand side. If you just add together that thing, it's just distance apart. So it's going to be what? It's going to be just 3, right? 2.5 minus 2.5 and plus half on the right hand side. So this much is 2.5 and this much is half. So I'll add this 2.5 and half. So I'll get 3. So this is going to be 3 into MB. MB is basically this distance, and this will just give me the coordinate, that is 6. So it's going to be into 6. So as you can see, it's going to be 9. Okay. So area of triangle AMB is going to be 9. Now what about this MBCD? So see, we are finding area under the curve, this BC. So obviously we want BC. BC is nothing but y, which is nothing but I'll just make this y as the subject, which is nothing but minus 3 by x. So this is going to be integral something to something, of course minus 3 by x, and it is from this point, that is 1 by 2, to this point, which is 1. So x coordinate is varying from 1 by 2 to 1. So 1 by 2 to 1. So which is going to be minus 3 constant outside, it's going to be ln x, and I'll just put it 1 by 2 to 1, which is nothing but minus 3 ln 1 minus ln 1 by 2. As you can see, ln 1 is nothing but 0, so it's going to be minus 3 into minus ln of 2 to the power of minus 1. I'm just using some ln properties. This is going to be minus 3 into minus 1 will come here, so it's going to be ln 2. So at the end I'll get minus 3 ln 2. But but the thing is, they have asked you in the form of p plus ln q. So area, what we are going to get? We are going to get area as 9 minus 3 ln 2. But the thing is, we are going to add it. Why? Because see, we are getting negative area because it is negative area like this, it's area under the curve of that negative side. That's why we are getting negative. But we cannot have area negative, so that's why we'll just make it positive. So we will just write this thing as 3 ln 2. So area, total area is going to be what? It's going to be 9 plus 3 ln 2. But since they have asked you in terms of p and q only, there is no coefficient of ln 2 or whatever. So we'll just write 9 plus ln 2 to the power of 3. Again, I'll just move this 3 up. So it's going to be 9 plus ln 8. If you want, you can put it in decimal and get the answer. Now this is another question you got. Oh, the sequence got messed up actually. B is first, A is second. So just please take care of it. Sorry. Now, given that integral 1 to a 1 by x minus 1 is nothing but ln 3 where a is greater than 0. So they may ask you that they have given the integral value and they are just asking you to find the value of whatever, the a, the limit. So it's just a different kind of function. Giving your answer in simplest third form. So they are not asking in decimal and all. So again, 1 to a 1 by x minus 1 upon 2x plus 3. We'll just try to integrate that. So it's going to be what? It's going to be 1 by x integral is nothing but ln x minus, see, I can consider this thing as x if I just make it 1 by 2, and now I can consider this thing as x is going to be ln of 2x plus 3, again from 1 to a. If you want, we can combine, or let's keep it as it is. Oh, we are going to combine because ln 3 is there on the right hand side, so it's better if we just combine it. So it's going to be what? It's going to be ln x minus ln root 2x plus 3, again from 1 to a. This is nothing but, if I just this is nothing but ln a minus ln b is nothing but ln a by under root 2x plus 3. Yeah, makes sense. And again from 1 to a. And now finally, if I just substitute, I'll get ln a by root 2a plus 3 minus ln 1 upon under root 2 into 1 plus 3, so again 5, and that is nothing but ln 3. So at the end of the day, I'll get ln a upon root 2a plus 3 divided by 1 upon root 5, which in turn will give me root 5, is nothing but your ln 3. Finally, left hand side, right hand side same, so I'll get a root 5 upon root 2a plus 3 is going to be 3. Just ln both sides that way. And finally, I'll square it and just I'll make a quadratic equation. So I'll get a square into 5 is equals to 9 into 2a plus 3. I just squared it and I just shifted everything on the right hand side. I just moved it here and then I squared it. So it's going to be 5a square is equals to 18a plus 27. And that in turn will give me 5a square minus 18a minus 27 is equals to 0. So here 5a square, now I don't think so. We'll have to use formula method, or I think we can just directly use calculator because it's a 6-mark question, it's function, and we'll just use calculator directly to get the value of a. So with calculator you'll get 9 plus 6 root 6 by 5, and you will get 9 minus 6 root 6 by 5. As you can see, this is a negative value. We cannot have negative value under log, or basically here where a is greater than 0, so obviously we are not going to take any negative value inside that thing. So obviously we are just going to get one value, which is 9 plus 6 root 6. So that is nothing but the value of a. And now let's talk about this b question. Find the exact, this is not dependent on that problem, so it's okay, sequence doesn't matter. So 0 to pi by 3, 2x plus pi by 3 minus 1 plus cos 2x. So what we are going to do, we are just going to integrate. So let's see, first sine 2x plus pi by 3. So what we are going to do, we are just going to put 1 by 2, the coefficient of x. Then it's going to be minus cos of 2x plus pi by 3. Why? Because we can just consider that thing as x. Minus x plus okay, again one sec, it's going to be 1 by 2, because since it is cos 2x again, and then integral of cos is nothing but sine, so it's going to be sine 2x. I hope I'm not doing it wrong. One sec, 2x 1 by 2. Yep, from 0 to pi by 3. Now at the end of the day we just need to put the values. So it's going to be minus 1 by 2. I'll just write it first properly. Minus 1 by 2 cos of 2x plus pi by 3 minus x plus sine 2x by 2. Okay, again from 0 to pi by 3. So I'll just substitute pi by 3 here. So I'll get what? I'll get minus 1 by 2 into cos of 2 into pi by 3 plus pi by 3 minus pi by 3 plus sine 2 pi by 3 upon 2 minus half into cos of 0 plus pi by 3. Make sure that you write put the brackets properly. Minus 0 plus sine 2 into 0. So at the end this is going to be 0 only upon 2. So let's solve one by one. So this is 2 pi by 3 plus pi by 3, which is nothing but cos pi. Cos pi is nothing but minus 1. So we'll get what? We'll get 1 by 2. Minus 1 by 2 into minus and so on. Then this is minus pi by 3. Sine 2 pi by 3. So this is nothing but pi minus pi by sine pi by 3. Sine by 60 root 3 by 2. So we'll get root 3 by 4. Because this is sine pi minus pi by 3. Sine pi by 3 is nothing but root 3 by 2. So we will get this thing as plus root 3 by 4. Finally, minus minus will become plus. So plus half into cos pi by 3. Cos 60 is going to be 1 by 2 again. Minus 0 as it is, and this is going to be 0. That's what you will get. Okay, fine. So this is going to be 1 by 2 minus pi by 3 plus root 3 by 4 plus 1 by 4. So at the end 1 by 2 minus 1 by 2 plus 1 by 4 and all these things we are getting. Just a second. So this is going to be 3 by 4 plus root 3 by 4 minus pi by 3. That's going to be our answer. This is all you have in integration. Yeah, it took a lot of time.